Alright guys, so in this video we're going to look at how primitive and reference type data is stored in memory. And one thing I want to mention is if you're a beginner and some of this is kind of confusing, that's okay. This is kind of like behind the scenes stuff. And the reason I'm putting it in the course at this point is just to give you a bigger picture of not only the syntax to write for your JavaScript code, but to also understand how JavaScript works. So if you don't completely soak in this video, that's absolutely fine. You can always come back to it later, and we'll talk more about this stuff later as well. So when we store our data, when we set a variable, if it's a primitive type, it's stored in an area in memory called the stack. Okay, if we store a reference type, such as an array, an object, a function, that's stored in an area of memory called the heap. Okay, so you have the stack, which is where your primitive data is stored, and you have the heap where your reference types are stored. So just keep that in mind. All right, now to kind of visualize how we store and access data, I created this diagram with kind of multiple scenes. So first off, let's say we create a couple variables. We have a name that's equal to John, which is a string, which is a primitive type, and then age equals 30, which is a number, which is also a primitive type. Now this box over here represents the stack in memory. So you can see age, the name of the variable, and 30, the value, are stored on the stack. Same thing with name and John. Now, if we were to create a variable called person and set that to an object, which is a reference type, you can see the variable is stored on the stack, but it accesses the data by reference, and that data is stored in the heap. All right. Now, just to kind of show you more about how this works, if we create another variable called new name and we set it to name, okay, up here, which is John, then on the stack we have a new variable called new name, and we have a new piece of data called John. Name is still equal to John, and now new name is equal to John. Let's say that we want to take that new name variable and reassign it. Remember, when we use let, we can reassign. So now we have new name equals Jonathan. So it overwrote the old value of John to Jonathan. Now let's kind of do the same thing and say, well, we're going to create a new person variable and set it to person, which is this object right here, Brad, name Brad, age 40, 41 now, but that's fine. So new person is put on the stack, the variable, and it points to the same reference that person does. Okay, so it doesn't create a whole new value like up here where we created John again. It just points to that area in the memory heap. So if we were to, let's come down here and let's say new person dot name, which is a property, this property right here, set that to Bradley. Now what's going to happen is we're changing in the heap that name value of Brad to Bradley. So new person dot name is going to be Bradley, but so is person dot name. In fact, right here, if we logged person dot name, it's going to be Bradley. Even though we changed new person dot name, the reason for that is because they both point to the same reference. All right, so that's kind of what I want to get across here is with primitive types, the value is stored on the stack. So even if you change new name to something, name is going to stay John because John is there. It's solid on the stack. With objects and arrays and so on, you have a reference. So if you set a variable to another variable and change something in that, it changes the reference. So what I want to do now is jump into VS Code and show you this exact thing in the text editor. So I have this empty script.js, and we're going to do the same thing. Let's say const name equals, we'll set that to John, and then we're going to set the age equal to 30. So these are both primitive values. In fact, I'll put a comment here, and let's say these values are stored on the stack. All right, now let's say reference values are stored on the heap. So let's say const, and we'll say person equals, and let's set that to, let's say name. And we're going to have an entire section on object literals like this, so don't worry if you don't fully understand the syntax. So we'll say age 40. All right, so we have our primitive values and we have our reference values. So I'm going to do what we did in the slide, and let's say new name, and I'm using let here because I'm going to reassign it. So we'll say new name, set that to name, and let's just do a console log down here of both name and new name. So now we get John and John for both the name and new name. And don't worry about this being crossed out. It's just because name is a deprecated property on the window object. It has nothing to do with what we're doing. So now let's go ahead and reassign. We'll say new name, and we'll set that now to Jonathan. So if I save that, now we get John and Jonathan. Now let's try the same thing with the reference type. So I'll say let new person, set that to person, and then down here let's console log person and new person, and we get both, they're both the same, right? Name Brad, age 40. So now what I'm going to do is take new person, which I got the value from person, but remember these are stored in the heap and they're accessed by reference. So if I were to change the new person name to Bradley and I save that, notice both person and new person both are now Bradley. Okay, because these are both stored in the same spot in the heap, and they're being accessed by reference. And that diagram should really help you understand why it's doing this, right? You can see they're both pointing to the same spot, but with the primitive values, the values are stored right on the stack. All right, so I hope that this made sense. In the next video, we're going to look at type conversion, because sometimes your types can change, whether it's implicitly or explicitly. So we're going to talk about that next.